sides, angles in a triangle. Okay, let's draw a triangle first. So you already know triangle has three sides. Let's change the color. It's going to draw a green. Okay, one side, that's longer side. Okay, that's a good triangle. Now we will talk about the relation between sides and angles. Let's say A, B, C. Okay. BC is the longest side here. And what's the smallest side? AB. AB is longer than AC. So AB shorter than, sorry. AB is shorter than AC, is shorter than BC. If we know that one, if that's given. So there's a relation between these sides and its angles. As you see, AB is here. Opposite of this AB, we have angle C. That's angle C or angle ACB if you want to write along like the vertex C, so the angle at the vertex C. That's the smallest angle. Okay, that's the first. Let's clean that one. Now, second AC. AC is that one. Opposite of this AC, angle B. So B is the here, B greater than C. And the longer side is BC if it's given. So the greatest angle is angle A. These are the angles. So there's a relation between side and angles. And it's true for both sides. If the order of angle is given, so you can check, say this is given at the moment, let's say. Angle A is greater, so opposite of angle A, the BC. So BC is the greatest side. Then angle B, so AC. Then, so opposite of angle B here. Then C, it's looking to angle AB. AB is the short side. So one of them given. If this order of angles are given, you can order of the sides. If the order of sides is given, you can order all the angles are. That's a theorem in your book. You can read it. It's the same idea. It's given one by one. So short side looking to short angle. Triangle inequality theorem. We will solve examples after explaining that one. First, we will solve example of these ordering issues. Okay. If we form a triangle all the time, let's say AB. AB all the time shorter than sum of AC plus BC, the other. AC plus BC. So when you AB must be shorter than sum of smaller than sum of AC and BC, sum of the other side. So one side all time is smaller than sum of the other side. Let's say BC. BC must be smaller than AB plus AC. That's the rule. So it's written here. You can say all the time one side is less than sum of two sides. As a reason of this theory, you can say any side. You can find only side. Let's say BC. BC all the time smaller than sum of these two. Is that true? Yes. AB plus AC. And it's all the time greater than AB minus AC. So I will use this absolute value because when you find the difference of two things, it must be positive. When we talk about length, the difference between two lengths, it must be positive. So therefore, I am talking about lengths. I use here absolute value because it can be negative when you subtract two values. Such as what? Let's say this is 3. Let's give some value. 3, 8, 6. 8. Is 8 less than 3 minus 6? 3 minus 6 negative 3, so 3. 3 is less than 8. Is it less than 3 plus 8? 3 plus 8, 11. Yeah, that's true. If this is true, so you can say this is a true triangle. You can form a triangle with these given lengths. If it's not, you cannot form a triangle. You don't need to check all of them. Only put one side at the middle. So at the other side and find the difference between the other side. If this statement is true, so we can form up triangles. We will solve some example later. on the video. Okay, write the angles in order from smallest to largest. So if you want to write from smallest to largest, what is the smallest angle here? Oh, that's PQ. Let's say this is R. Okay. Now the smallest side is 4.5. It's looking at the Q. So Q is the smallest angle. After them 45. And 45, as you see, P. P is the second angle. And the greatest side is 57. And it's looking to R. R. Here, another way you can use if you do. PQ is longest one. PRQ angle. PRQ is the longest angle. Or PR the RQP or PQR, that angle. There are two name way give the angles. If you know how to name the angles, you will not get any problem with that one. Look at the second example. The angles are given, but two angles are given. How do we calculate this one? Let's say this is angle Z. 39 plus 46 plus Z equal 180. This for a triangle, it's all time 180. 3 minus 1, 3 minus 2 is 1. 1 times 180, 180. If you remember some of the interior angles. So 39 plus 46, 85 plus Z, it's equal 180. Z equal 95. So Z is the greatest one. That's 95. So this side is the longest side. But it's asking the shortest. So 39. Let's use a blue color here. 39, and which side is that? YZ. 39, the vertex is X, so what is that? YZ. YZ. After then, 40Y, it has the Y, so XZ. Okay. XZ. Let's clean that all here. I already find 39, so 46 is looking to XZ. Then, that's 95, it's looking that side, that's XY. So when you know order of the angles, you can order the sides. Tell whether a triangle can have sides with the given lengths, explain why. So, this question asking if the given values form a triangle or not. So what is the rule? There are two ways to solve it. I will show one of them in the first example. I will show the second way for two of them. Let's show the first one first. This side 4. It must be less than 7 plus 10. Yes, true. 4 is less than 17. This is true. Is 7 less than 4 plus 10? Yes, 14. This is true. Is 7 less than 14? This is true. Is 10 less than 4 plus 7? Yes, 10 is less than 11. This is true. If three of them true, three statements is true, so these values can form a triangle. These lengths show the triangle's length. That's okay. A triangle can have these lengths. That's okay too. But I don't want to use this method. This method, as you see, is take lots of steps. I choose 1, 4 at the middle. So I add these two, 7 plus 10, and I subtract this 2, and it must be less than 4. 7 minus 10. Be careful, I use here absolute value, because when we talk about length cannot be negative, so I will use absolute value. I want to find the difference between 10 and 7 is 3. So 7 minus 10 actually. 7 minus 10 is, so that's 3. Less than 4, less than 17. Is that statement true? Yes, that's true. So it's form a triangle. A triangle can have this length. One more example for that one. So you can try rest. I choose 2 at the middle. So 12 minus 9. It must be less than 2. It must be less than 12 plus 9. 12 minus 9, 3 is less than 2 is less than 21. As you see, 3 is not less than 2. Statement is false, so a triangle cannot have these lengths. You can try the two examples. I want to solve one example with the variable. What is x? 5. So if these are the sides, 3 times 5 and 5 minus 1 and 5 squared. These are the sides. 15, 4, 25. Can a triangle have these lengths? Let's try. 15 must be less than 25 plus 4, and 15 must be greater than 25 minus 4. So 25 minus 4 is 21. I can use absolute value, but it doesn't make change because it's positive. The for me important, but this must be positive. So is less than 15, is less than 29. So as you see, is that statement true? No. 21 is not less than 15, so these cannot form a triangle. Last example about this section. As you see, the length of two sides of a triangle given, find the range of possible lengths of the third sides. So I need a third side. I will call this third side L. So what is the rule that I use all the time? L must be less than 12 plus 8 if it's a triangle, and it must be less than 12 minus 8. Use absolute value, no problem. 12 minus 8 is 4, is less than L, is less than 20. So if it's a triangle, the third side, the length of the third side must be greater than 4, less than 20. You can use same method for the rest of the examples. That's the end of this video. Thanks for listening.